Hello students, today we are going to see about the color coding of a resistor. A resistor is a very small device. So, we usually cannot print the value, its resistance value on the resistor. It will be difficult to make such a small print. So, we use different colors for mentioning its resistance value. That is called color coding of resistance. Let us see. Usually, if I take a resistor, this resistor is called carbon resistor. Resistor is made up of carbon. There are three rings: first ring, second ring, and the third ring. Those three rings together will give the value of a resistor. So, I can just say like this: the first number of the first ring will show, the color of the first ring will show the first number, the color of the second ring will show the second number, the color of the third ring will give the power of 10. Okay, give the power of 10, and so those three things can give you the resistance value. And you can see a fourth ring is kept at the end. That ring will give you the value of tolerance. Tolerance means how much the value is changing, how much is the variation in the value. If it is 1 ohms, see for example, if it is 100 ohms and the variation is 5%, that means that 100 ohm resistor can have a value between 95 ohms to 105 ohms, plus or minus 5. So, that is what is called tolerance. So, let us first see the color coding. So, the first ring and the second ring will give the first and the second significant numbers, whereas the third ring indicates the decimal multiplier. So, you can see this color coding. Brown, black, brown, red, orange, yellow, green, blue, violet, grey and white. And I have given the numbers from 0 to 9. So, the numbers, the significant numbers that each one corresponds. Now, if it is a third color, then instead of 3 I will write 10 raised to 3. Okay. Or instead of 5 I will put 10 raised to 5, because the third color stands for the multiplier of 10. Now, I told the fourth ring. So, fourth ring can have only two colors, gold or silver. If the fourth ring is gold, the tolerance will be only 5%. If the fourth ring is silver, the tolerance will be 10%. And if the fourth ring, there is no fourth ring, then the tolerance will be 20%. So, let us just see some example. So, before that there is an easier way to study this color coding. Just see this: B.B. Roy of Great Britain has a very good wife. B.B. Roy of Great Britain has a very good wife. All the capital letters that I have written corresponds to these colors. So, using that mnemonics, you can easily remember the color codings. Okay. Now, I have just mentioned some examples. Just see. First color brown, then comes violet, then comes black. So, three colors I gave, and the fourth one is gold. So, let us just look this. Brown is 1, and then comes violet. Violet is 7. So, I wrote 17. Third color is black. Black is 0. So, I put 10 raised to 0. What is 10 raised to 0? 1. So, the answer is 17 ohms. This is the gold. So, tolerance is 5%, plus or minus 5 ohms. Now, see the second one: green, red, blue and silver. Green, just see here, 5. Red, 2. So, I wrote 52. Then the third color is blue. Blue is 6. So, I wrote 10 raised to 6. Then that is silver, so plus or minus 10%. Okay. Now look the third one. Here there is no fourth band I have put. I just put a brown, violet and black. Brown is 1. Violet is 7 and black is 0. So brown is 1, violet is 7 and black is 0. So 17 into 10 raised to 0. So 17 plus or minus 20 ohms. Okay. So that is how we can find the resistance using the color coding. Now series combination of resistors. We have studied this derivation in 10th. So we are not going to do the derivation. We are just saying the things. When resistors are in series, current remains same and potential difference will vary. Okay, when resistors are in series, current remains same, potential difference will vary. Just make a note of that. So the total resistance will be R is equal to R1 plus R2 plus R3. Now for parallel combination of resistors, when resistors are in parallel, there you can write potential difference remains same, current will vary. So the effective resistance is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now just note down this, when the resistors are in series, the total resistance will be greater than the greatest of all. That means if one resistance is 10 ohm, another is 5 ohm, another is 2 ohm. The answer will be obviously greater than 10. That is what I mean. Similarly, here R is smaller than the smallest of all. That means if 3 resistors are 10 ohms, 5 ohms and 2 ohms, when I take them in parallel, the answer will be lesser than 2 ohms. That is why I told R is smaller than the smallest of all. Okay. So the equation is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, so on. If there are 2 resistors connected in parallel, I can directly use one equation for 2 resistors in parallel. I can use R equal to R1 R2 by R1 plus R2. This is applicable only for 2 resistors in parallel. Okay. For any other one, you have to use that equation itself. For 2 resistors, it is R1 R2 by R1 plus R2. Now suppose if there are n identical resistors, for n identical resistor, identical means the values are same, all the values are same, that is called identical, such that there are n resistors. So in series, if there are n resistors in series, then Rs is equal to n into R. I wrote the subscript S for mentioning it as series. Now if they are in parallel, then Rp is equal to R by n. Rp is equal to R by n. So for series, Rs is equal to n into R, and for parallel, Rp is equal to R by n. So please make a note of this. Now what is meant by EMF? What is meant by potential difference? Potential difference we already know. If only there is a potential difference, the current will flow. If there is no potential difference, no current flow. So what is the difference between EMF and potential difference? That is what we are going to see. EMF or electromotive force, it is the maximum potential difference between the 2 electrodes of the cell when no current is drawn from the cell. EMF is the maximum potential difference across the cell when there is no current flows through the cell. That means EMF is the potential difference in the open circuit. Okay, EMF is the potential difference in the open circuit. When the circuit is open, no current flows. Now, what is terminal potential difference? The potential difference is the difference of potential between any 2 points in a closed circuit. So, when the circuit is closed, the voltage in any 2 point is called potential difference. When the circuit is open, the voltage across the cell is called EMF. So, I have just given the comparison of EMF and potential difference. The first point we have already discussed. The second point, it is independent of the resistance of the circuit. Why EMF is independent of resistance? Because current is not flowing. So, resistance, there is, even if I have connected a resistor, it has no value because current is not flowing. That is why it is independent. But potential difference is proportional to the resistance between the given points, because V is equal to I into capital R. So, if capital R in a circuit is more, the potential difference is more. For example, I have connected 2 resistors, one of 5 ohms and another of 10 ohms. Same current is flowing. So, the voltage, the potential difference across 10 ohm resistor will be greater than the potential difference across 5 ohm resistor, because of the equation V is equal to I into R. When R is more, potential difference is also more. That is the second point. Now, third one, the term EMF is used only for the source of EMF. That means for the battery. EMF is only used to mention the potential difference of the battery in the open circuit. Battery or a cell in the open circuit. Potential difference is measured between any 2 points of the circuit. Always what we are measuring in a circuit, what we are measuring is the potential difference. Now, EMF is greater than the potential difference between any 2 points in a circuit. This is during the discharging time. So, during discharging means the current is flowing out through the cell. Current is flowing out from the cell, that is called discharging. At that time, always EMF will be greater than the potential difference. The value of potential difference is lesser. Whereas during charging, you know, we are putting the mobile phones for charging. So, the battery, the current is flowing into the battery. During discharging time, the current is flowing out of the battery. During charging time, the current is flowing into the battery. So, at that time, the potential difference will be greater than the EMF. So, please keep a note. During discharging, EMF is greater than potential difference. During charging, potential difference is greater than EMF. So, you can just write 3 things here. First one, in open circuit, V is equal to E. In open circuit, V is equal to E. That means EMF and potential difference are same. Now, during discharging, V is less than E. Terminal potential difference. Terminal potential difference means potential difference across the terminals, that is less than the EMF. So, this terminal potential difference at this time, this point of time, can be found by the equation V is equal to E minus I into R, small letter r. I am not writing capital letter R, I am writing small letter r, where small letter r is called internal resistance. Internal resistance means resistance inside the cell to the flow of current. That is called internal resistance. Resistance inside the cell to the flow of current. So, V is equal to E minus IR. Now, the third point that you have to mention is during charging. During charging, V is greater than EMF. So, at this point of time, I can write V is equal to E plus IR. Where R is the internal resistance of the cell. So, these equations and these conditions please note down. So, that is all for today. Thank you.